Um, Hello everyone. In this video, I will present a classification process using the Sonar dataset in AI Studio. The objectives are to analyze the dataset, apply several classification models, evaluate them using cross-validation, compare ROC performance, select the best model, and perform hyperparameter tuning. First, I retrieve the Sonar datasets from the sample repository, and the Sonar dataset is a binary classification dataset. The goal is to classify each sample as either rock or mine. Okay, as you can see the set row here, example set data here. Each row represents the Sonar signal data, and target class here shows whether the object is rock or mine. Since there are only two classes, so this is a binary classification problem. Okay. Next, I use the set row operator to define the target variable. Here I set the attribute class as the label. This means that class is the variable that the model needs to predict, while the remaining attributes are used as input features. After setting the label, I use multiply operator. The purpose of this operator is to create several copies of the same dataset, so I can compare multiple classification models in the same processes. Each brand receives the same input data and used for a different classification model. For model evaluation, I use cross-validation. In this process, each model evaluated using tenfold cross-validation here. Tenfold cross-validation divides the dataset into 10 parts. Each round, one part is using for testing, and the remaining parts are used for training. This gives more reliable results than a single train test split. Okay, so next we move inside the cross validation here. Inside the cross validation operator, there are two parts: training part and testing part. Okay, in the training part, I place the classification model. For example, this KNN model here. In the testing part, I use apply model to apply the trained model to the test data. Then I use performance binomial classification to evaluate the prediction results. Since the Sonar dataset had two classes, rock or mine, I use performance binomial classification. This operator is suitable for binary classification problems. I evaluate the model using accuracy, AUC, precision, recall, and F measure. AUC is very important because the assignment requires ROC comparison. So in this experiment, I test 6 classification models. They are decision tree, random forest, logistic regression, SVM, KNN, and naive Bayes. All models are evaluated using the same tenfold cross-validation setting, so the comparison is fair. Okay, after running this model, I have a result here. I run this model before, so I have the result here. And based on the accuracy, you see here, result here. You see the recalls, F measures here, and as we can see, the KNN has the best value here, and I choose KNN is the best model to turning. Okay. To satisfy the ROC comparison requirement, I also use the compare ROC operator here. Here I compare all six model here inside the compare ROC operator. Okay, so I have the result here. The ROC curve shows the relationship between true positive rate and false positive rate. The best model has ROC curve close to the top left corner and higher AUC value. So, in this experiment, the KNN has the highest AUC here, 0.894, when the other model is only 0.809, like 0.616 here, 0.855 here. After selecting KNN as the best initial model, I perform hyperparameter tuning here. For KNN, the most important hypermeter is K, which represents the number of the nearest neighbor used for classification here. I use optimized parameter grid to test different value of K. The test value are from 1 to 15 here. I set this before, and I use AUC as the main criterion because AUC is suitable for binary classification and ROC comparison. Okay. Here's after running the this model, I have the result here. After tuning, the best result is when K is equal 5 and the AUC is 0.902. Okay, so in here. After turning the KNN, the accuracy is equal 81.67% here. The AOC is 0.902. The recall is 88.26%, and the F measure is 83.86% here. The confusion matrix show that the model correctly classified here. The confusion matrix. The model correctly classified 72 rocks and 98 mine. It misclassifies 25 rock and 13 mine. So in conclusion, I tested 6 classification model on the sonar dataset using 10-fold cross validation. I also use compare ROC to compare the ROC performance of the main model. Among all tested model, KNN achieved the best initial performance. After hyperparameter tuning, the best value of K was 5. So, thank you for listening.